Good morning and welcome to our webinar on 3 tips to prepare your data for AI. We're going to give it just one more minute and then we'll go ahead and get started. Okay. Well, thank you so much for taking the time to attend our webinar today. Today, we're going to talk about how to prepare your data for AI. My name is Andrew Kreider. I'm the Director of Analytics here at LumenData. I also have Nimesh with us. He's our chairman and co-founder at LumenData. He's going to give a brief presentation on who we are, and then we'll dive right into the content. So with that being said, Nimesh, let me go ahead and advance the slide.
Yeah, well, thank you, Andrew, and welcome folks to this webinar. We are LumenData. We are a consulting firm based in, well, actually all over the US with operations elsewhere in the world. We have focused from our get-go on enterprise information management, and that means, of course, master data, data quality, governance, architecture, and those topics, but also cloud data warehousing, integration, and then more recently, the leveraging of all of this data, preparation and leveraging of this data for various analytical use cases, your regular descriptive analytics, predictive analytics, and generative AI use cases. One of the key things that we pride ourselves on is the quality of our team. It is very experienced. We are, I mean, if you know, I can say it so myself, we're really good in what we do, and our customers say so. We have many partners we work with as well. I'm happy to tell you more about them, but you can see them on the screen. And let's get to the topic at hand, which Andrew, who's our expert, will talk about, which is preparing data for AI, because AI or any other analytical deployment use case is not effective unless your data is in the right shape. And that's what we're here to talk about. So, Andrew?
Fantastic. So just who we are. Again, we are both leaders here at LumenData, and we want to talk a little bit about what we are hearing from our clients as we're talking about helping them get ready for, say, the generative AI applications that seem to be a big wave of everybody's plans for the next year. So first off, let's talk a little bit about what in the market right now is being pitched as generative AI solutions. A lot of people are creating chatbots to go over knowledge bases and stuff like that. But from a business standpoint, what we're really seeing is 3 main different use cases. The first one is for people who do a lot of composition of documents, is semantic search and proposal augmentation. So this is reducing the cost of building proposal and research by using large language models to kind of build out boilerplate information. And this is trained on what we would call non-structured data, previous SOWs, previous business proposals, things like that. Something where generative AI is really good at, which is consolidating a lot of information and then spitting out a regurgitation or a rephrasing of that document. The second one that we're seeing is with call center support and other support requirements that require kind of a personalization for the person that you're talking to. Both internal and external. This is trained on previous operation calls, support and chat calls, and knowledge articles to really help the call center team reach a solution to whatever the customer's problem is very quickly and personalizing it to the person who's calling in, whether it be an internal user for, say, call center support for technical support, or it's for a customer who is calling in for a question. And that leads us directly into the customer 360 grouping. This is designed to increase personalization, taking all of the information that we know about someone and all the offerings that we might have and building out a personalized solution for that client. So whether it's recommendations, whether it's personalized emails, whether it's custom marketing, anything like that that requires parsing over a large amount of data that is either structured or unstructured, and then returning a result. Now, this is what most people leap to, but as Nimesh so correctly said, all of this is valueless if you don't have clean data and data that's prepared for those specific cases. So the three things that we're going to talk about prepping your data right now is business outcomes. What are you trying to actually accomplish with your large language model? How to clean your data to make sure that it is the most accurate and precise, because for large language models, the more garbage you put in, the more garbage you put out. And then finally, we're going to talk about metadata, which is how computers understand the world in a sense of context, right? Knowing that Mississippi is the river as opposed to the podcast, as opposed to the dessert or something like that. So let's talk about business outcomes first. Whenever you do any significant events, any significant project, what you want to do is you want to ask three questions: why, what, and how. And in large language models, this is equally important. So the why is, what do your stakeholders want to do? What is the task that is taking the most time and can be automated the best? And then using that information to identify solutions that remove repetitive or reduce the time to impact. And then we want to ask what? Do we have the data that we needed? Over 90% of any large language model project is just making sure that the data is in the right format and getting all of that correct and clean. And then you also need to identify non-traditional data sources as possible sources of information for your large language model. This includes structured data like SQL queries, but this can also include information like YouTube videos or recordings of calls with clients or transcripts of Teams logs. Anything that provides more context and more information to the large language model is really good. And then once you identified everything that you have, what data are you missing? Can you go create it? Can you go find it? Is there any way that you can assemble that data to improve your large language model output? And then the final answer is, how do we use the results? Not everything is a chatbot, right? Sometimes you just need a Word document created. You don't necessarily need to go through an iterative process with a chatbot that pieces all the pieces together. You just need the final output. The second question is, can you use more data science and machine learning to find the trends or make recommendations that you can then augment with large language models? So consider breaking up the task into multiple different steps and be very laser focused on how you use your large language model implementations, because large language models are great at summarization and consolidating information, but without the proper context, without the proper data, it can create hallucinations or faulty data. And there's nothing worse than presenting data to an end user as it is the truth without actually it being the truth. And large language models cause a risk there. So let's talk a little bit about what a good first step of this would be, which is creating a recommendation engine within Databricks. So what we did as a POC for that you can find on our website is a Databricks demo that showcases how to create customer 360 data that's been cleaned, and we'll talk about that in just a moment, and then create recommendations for an e-commerce store. Now, this can be recommendation engines based on products, physical goods. The application is the same. So essentially what we're going to do is use the Databricks notebooks that are available natively and a number of Python libraries to create a recommendation engine by essentially just using past information of what people are similar buying, and then creating a recommendation engine that recommends 5 items, 3 that are specialized to that person's transaction history, 1 that is personalized based on the group that that person is from a demographic standpoint, whether they're male or female, whether they buy mostly kid equipment or home good decor, things like that. And then we're going to also put our little thumb on the scale, and the items that are the most popular or the most profitable for us, we're also going to recommend within that recommendation engine. And so as you can see here in this Databricks notebook, it's just about 30 to 40 lines of code to actually implement the recommendation engine after you've done all of your data cleaning. And what this allows us to do by essentially clustering the data based off of our clean data of our demographics, we're able to create a number of recommendations. And so instead of presenting this information as a chatbot, we're going to present it to a sales associate in a way. You select the customer that you want, and it's going to give us 5 items that we recommend to that user. And for every different customer, you're going to get some similarities and some unique items within that customer. And then what we can do with a large language model, which we're going to show in the next demo, we can then use that information then to create customized emails or objections for future purchases for that specific user. But getting the data into a single step is very, very important. And then presenting that data that is then can be surfaced into a CRM solution or into a customer call screen, or even at the counter in a point of sales opportunity there. And so the recommendation engine in itself is very valuable, because what we can then do is do a number of things with the output of that recommendation engine. Based on previous purchases, we can create a custom email to that user. We can send emails through custom marketing messages based off of our segmentation of demographics and psychographics. And if we wanted to, we could even feed this data into a chatbot, which creates a personal shopper experience. And this allows you to further personalize. And as you're tracking this data and keeping it clean and governing it, you can further augment the algorithm and decide on different things to surface up. Now, you might have heard that I mentioned clean data in a lot of that. So let's talk about our next way to prep data for AI, which is essentially to clean data. Trusting data is the only thing as data professionals that we really should focus on. Whether that's implementing a master data management solution in Informatica, or creating a business policy on how to continuously update and govern data, that's all very important so that we know what we're working with. The second thing is we need to apply business context. What are the most important metrics for your stakeholders? How are they evaluating the business? And what are the factors that change that data? When we're doing this work, Snowflake makes the most sense, because that allows us to kind of do that as well. And then when we implement it, again, we need to find another number of different ways to implement it. Perhaps we need to surface it in an email blast to our internal users, or send custom marketing messages. But one of the things that we've noticed as we're implementing these solutions is that to even further cut down on hallucinations and increase trust, we're creating a solution that has a person in the middle. Essentially, the large language model will put out some content, a person will evaluate it, and then that allows us to implement further changes and also iterate as we go along. And so as data professionals, when we're building a large language product, what we want to do is be aware with all our time and card, right? About 55% for rate in your data that can be large. Next step is doing that external augmentation that we talked about.
Hey guys, are you having trouble hearing Andrew? Tanush?
Yes, I think it's internet bad.
No, yes, as in you're having trouble or not having
Yes,
trouble?
yes, we are having trouble with that.
Okay.
We'll be back.
Yeah, sorry. Stand by for technical difficulties. We'll be right back, but yeah, we're going to do a couple of. Oh, there you are, Andrew.
Hi, yes. Where did I drop off?
You started on the whether it's master data. It's the master data, the slide with Informatica, Snowflake, and Python, I think it is.
Fantastic. My apologies about that. I must have had some internet connection issues, which was unanticipated.
Yeah.
Let me go back to this. So just so that we're all on the same page, essentially what we talked about here was trust, context, and implementation of a clean data solution. So the first step is trusting that data, implementing a master data management solution, say in Informatica, and then creating a business policy on how to make sure that that data is updated and governed correctly. The second thing that we want to talk about is context. We all define revenue differently. We all define churn definitely differently. And so creating the definition of the important metrics that our stakeholders are judging their business on allows us to properly do our analysis and build out those applications. And then we also want to make sure, what are the other inputs and sources that might change that underlying data? Or do we have customers coming in new? Are we writing that data to a data governed table? Are we working with material from Google Analytics for some of our e-commerce solutions? All those solutions add data to our system and can be placed in Snowflake for rapid access with large language models. We want to make sure that it is accurate and consistent. And then finally, the implementation step. So we talked previously about a recommendation engine that surfaces information up to our users through a point and click interface. And sometimes we talk a little bit about sending out emails to our end users via email. But what we want to do in all of these solutions is make sure that they are being regularly monitored with what we might call a person in the middle solution. This is where the large language model outputs data or outputs results, and a human verifies the results before sending it out. This can still represent a significant cost savings because most of the hurly-burly act of creating a personalized email is skipped over, but a human being is still reviewing the content to make sure that it fits within our messaging and inside the world that has been existed. And then we can use all of that information to iterate over our algorithms and our code, and then decide on new ways to implement those large language model outputs. And so when we're looking at it from a scoping perspective, what we have to be aware of that 90% of our work is actually done before we actually even write a single line of code for our large language models. A large percentage is data engineering, getting the data that we need, formatting the data that we need, removing PII information that is as appropriate, and then doing our data cleaning, consolidating all of our information into one single instance, augmenting that data with external data sources. And then the final 10% is really user input so that we can determine how effective our large language model outputs are, as well as finding new ways to utilize that output and doing some analysis as well to make sure that we are providing the right information and the right types of information to continue to refine our output from our large language models. So let's look at a Snowflake Customer 360 demo. And this is a number of different components. The first one is going to be an Informatica implementation that takes in all the information about our customers, right? So whether it's the employee that inserted the data, whether it's how they have kids at home, whether it's their last name or what their average purchase amount, what we've used here is Informatica Business 360 to create a master data governance solution so that we get from all of our records, from all of our different sources into single records for each one of our users. So we understand exactly the information that we need for that one user along the way. And with that information in Informatica and Snowflake, we're able to set up a number of different criteria to kind of analyze before we write a single code. So for example, let's look at, for a single day, let's look at the total amount of purchases by each one of our users, and not only what they purchased, but what they saved and what they viewed. And so we can see by just this very long list, a lot of people have saved and viewed items that they did not purchase. And what we are going to do then is look at those specific users. And because in this particular example, we're selling ski equipment, maybe those users need to have more hands-on experience with the equipment that they're buying. And so what we're going to do is that now with our governed data, we're going to find users who have the most shared, viewed, and saved information by zip code. Now, this is a zip code that we might want to look at to create a pop-up or to create another store to kind of facilitate the purchase of that data, purchase of that equipment. And finally, with that information, what we're going to do is we're going to focus on one particular user to use our large language models. And with this one guy, his name is Nathan Brown. What we're going to do is we're going to find the equipment that he has purchased, that he has saved, and that he has viewed. And this is where our opportunity really is to determine what he's bought and what other things we can convince him to buy. Now, all this information is only valuable because we've been able to household this one member into one person. We know he fits within our zip code demographic that has a considerable amount of revenue, personal disposable income, which we looked at with this query here. And this allows us to not only create the personalization, but also reduce the target list so that we can have a more accurate result set coming back from our interactions with him, so that we can refine our algorithm and refine our processing around the output of these large language models. So very simple. The first prompt that we're going to use with Snowflake Arctic, which is their large language model, is you are a sales associate chatbot. You need to come up with an encouraging line to send to the user to purchase an item in this list that they either saved or viewed. And we want him to be pithy. And then we provided some information that they have a large affluent family. And so when we actually run this when we run this prompt right here, what we're going to get in a very short period of time is we're going to get what our sales associate should do to call back to that user and introduce this new item that he should buy. So for the photochromic goggles that he did not buy, here is a great callback script or an email or a message over a chat bot of what might be really useful for that user to know about the item and to overcome the objection that they did when they didn't purchase the item. And regardless of what user we did, we're always going to be pithy. We know what kind of affluent family member they are. All of that gives us that personalization that we really need. And then something even more basic is that we can provide another set of information based off of his destination, which is a Colorado ski lodge. And given the list of the items that he's already bought, let's create an email that lays out an itinerary that emphasizes all the things that he bought during his trip to our store. And so when we look at this itinerary, it knows where he's going to be, it knows when he starts, and it knows what he bought. And so we create an agenda for his day so that he's able to actually walk through his entire day, enjoy all of the items that he got from us. And with that information, we can pass that information along to the third party, to the Colorado ski lodge, to give them an itinerary of what he should be doing so they have extra upsell opportunities. So what did we do with that right there? What we did was do a number of things with this personalization, right? Over multiple interactions, we created a true understanding of each customer. We analyzed where our customers lived. We used our customer understandings and their salary to find our prime customers. We helped prepare our team for objections. And then we enhanced his experience to his ski lodge with Gen AI. Now, all of this was only valuable because the data that we had about this one particular person was accurate, was correct, and truly represented who he was. So without that 80–90% of work that we did on the data engineering side, this last 10%, where the true values created with LLMs would not have been possible. So let's talk about the final thing that we want to do. The final thing is metadata. Metadata is how we describe the world to a computer, how it knows that the Mississippi River and a Mississippi pie are two different things, how the context that we already described, what is an affluent member, how much disposable income they have, how their age and other demographic information dictates their buying patterns. All this information is super critical for our personalization, right? And humans are really good at understanding this and building these rules. But to communicate it to the computer, which is naive in the sense that it only knows what it knows, it doesn't know everything that it doesn't know, we need to describe it via metadata so that it can be consumed and then build its understanding and its results based on that information. And then finally, putting those two together, putting humans and computers and large language models together, we can distinguish between correlations and causations. So a computer will output, these things seem related, but we don't know, it doesn't know whether there's a correlation or a causation there. And so with humans, we can parse what the computer outputs out as correlations and distinguish between the things that are important and go back and iterate over our large language model output, and which ones are correlations, which are nice to know and perhaps nice to display to our users, but don't have any action taken inside of it. Recently, we were talking to a client, and they have around 2,000 Tableau reports. They don't know what's in them. They don't know what format the data is being presented in. They don't know what the metadata around those reports are, but they do have the data being tracked in Informatica in the data lineage. And so what we did was we built this very simple POC architecture for them, which is pulling images and workbook information along with other report metadata out from Tableau, and then data lineage as well out of Tableau through Informatica's Tableau data connector. And with those two things, we now have the context to tell our large language models how to search and interact with this report catalog. So we're going to use Llama 3 or whatever the latest version of Llama is with them, along with a vector database to build two things: a recommendation engine so that users can easily find the reports that have the information that they want in the format that they want, and then also a natural language processing chatbot to kind of make suggestions of what reports should we consolidate, what reports have duplicate data, what are all the sources of a single database table. All of this kind of stuff will allow us to present this data in multiple ways. But the first thing that we need to do, which is the first half of this diagram, is extract out the metadata. And so for that, we're going to have two different sources. We're going to have Tableau images and workbooks, and we're going to extract out image information from the images to build out most of our metadata. And then we're also going to use the lineage data to kind of track all the way through. So on the right-hand side, you can see what this Tableau dashboard information looks like. And so we're going to be pulling out things like the title of the dashboard, which we're going to get from the image of the dashboard. Metrics, what metrics are there? A summarization of that, what department it might fit in, what the computer thinks is the most important metric. Again, this is another reason why we want to include person in the middle here. And then metric definitions that are defined from the Tableau workbooks, along with the report SQL that's actually being run, which will allow us to go back through, find all the sources and all of the different tables that populated into this Tableau report catalog. So let me show you kind of what this looks like real quick. And so, for example, we have a dashboard that looks like this. This is a CMO dashboard. Has a title, have a number of different metrics all the way through. Here's another dashboard that is more finance related. And here's a call center dashboard that is more operationally dependent. And so what we've done is two things, is we defined what the metadata looks like. The Tableau dashboard information. So we're going to pull a number of different things, the title of the dashboard, the metrics, what charts are present in the dashboard, an executive summary that we can use to provide that information out, what department, and then a guess of what the most important metric is. Now, because we're using a vision dashboard, a vision processing here, we're going to be using Gemini in this instance for this demo. When we run this, what we get is it's going to run over the 5 dashboards that we have in our report catalog here. And as you can see, it's outputting all of this raw data here. And so for each one of these outputs, we get a formatted data that we can then import into our vector database with all the metadata and context that we need, and that we can augment then with a number of different other sources like Tableau Lineage Connector and Informatica, as well as the report definition from Tableau. But as you can see here for the CFO dashboard, we have a CFO dashboard, a listing of all of the metrics there, what kind of charts are there, and then an executive summary of every single one of the reports, and then a guess of what the most important metric is. I will need to go back and qualify this with the users, but this is a very easy way of just looking at an image of a dashboard, just looking at an image of a website. You can get some basic understanding of what the computer sees as the most important, and that can help you really build this iterations all the way through that gets you to that endpoint. So what can we do with all that information? There's a number of different things that we can do. So the first one is doing how we're going to use it, which is a report landscape evaluation. We can process an entire 2,000 data set in a matter of hours, as opposed to someone manually doing this, which would take a month or 2 months. We'll be able to identify the full report catalog. We'll be also able to identify data elements, the models that are being utilized in the backend from a data perspective, as well as information from the Tableau server on how many times a report is accessed and who's accessing it. And with that information, we can then go into user interviews, and we can identify with groups of reports how they're being used and where they might be having some problem doing some calculations. And then what we can also do is we can surface those results as discussed, either via semantic search or through a natural language chatbot. And then finally, this sets us up to do a number of different things. So for example, when a ticket is created, we can provide all this metadata to the data engineer or data visualizer who's working with all the tables, with everything that they need to refine or modify a report with just a very simple query to the natural language chatbot. We can also identify optimization and report consolidations by doing semantic search. We can surface new information. For example, if we're asking what is causing that revenue shift, we know what tables and what SQL is being run, and then we can charge the large language model to create another query to identify what might be the changing factors on that dashboard, really further expanding the capability of your reporting environment. So let's wrap up. there are three distinct ways that you need to prepare your data for large language model processing. The first one is business outcomes. Why are you doing what you're doing? How are you going to do it? What data do you have? And then the second part is cleaning the data, right? Do we have the trust in the data that we've provided? Have we provided the proper context for the data so that we understand what key metrics are? And then third, how are we going to implement it? How are we going to refine it? Are we going to surface it up via email? Are we going to surface it up via chatbot or recommendation engine? All of these different parts allow our users to trust the data that they're getting from the large language model so that they can continue utilizing the incredible power of it. And then finally, metadata. What's the context of the questions that are being asked? Where's the human interactions? Overcoming the naive nature of computers and large language models. And then finally, defining correlation and causation and how to treat both of those differently when we present that information to our users. And the final thing that I want to touch on before we go into an audience Q&A is kind of our expertise. Whether it's Databricks, whether it's Informatica, whether it's Snowflake or AWS, LumenData has experience in all of this tech stack so that we can take your business problems and turn them into technical solutions so that you get the value out of large language models that you want and need. And so with that, we're going to open up the floor to any questions that we might have. And then we'll talk a little bit about where we go from here.
All right. Well, thank you much, Andrew. Really appreciate it. I have some questions that have come in, but also if we have questions, please put them in the chat. Okay, so on one of the questions is, when you look at LLMs and Gen AI technologies in enterprises, you don't see a lot of it being deployed as of now. I mean, there are some deployments, and yes, chatbots and things, but what do you think is the reason for that? And how do you go about changing that for the benefit of a company?
So I think the very simple answer is this slide right here, right? As we've discussed throughout this, the data is the most important part, and that's often the most expensive part. And so I think that a lot of our enterprise customers, especially the ones that we're talking to, they want to jump directly into a chatbot where really they need to take some time, and they fail, right? Because the underlying data is not been resolved. The issues in their data have not been resolved. And so when we talk to a customer about that, one of the things that we talk about is how can we refine the scope to a point where stakeholders can get true value out of it. Instead of trying to boil the ocean, let's solve one repetitive task and then do the data engineering and data cleaning for that one particular use case and then expand it out. I think there's some FOMO out there in the universe that they have to have a chatbot, but if we can, but if they focus more on a specific repetitive task to reduce their costs on, they can find some real value.
Yeah. Well, thank you. Yeah, that makes sense. The other question we get or have is one of concern of inadvertent release of confidential data, right? Even within the company. So you imagine a company which where you're trying to do some of these model deployments, and there's some data like, say, sales forecast data for the quarter, right, that you want to be very careful with because you do not want that out there because, of the obvious reasons. Financial data, I mean, there's many such use cases. How do you put the guardrails in one of these deployments so you don't end up in that situation?
Right. So I think a really good example of that is how we handled that situation in our Snowflake demo, right? So for example, here we have a whole number of different factors here that we don't necessarily want to release to our chatbot, right? So social security number, salary, and you can imagine, you can extrapolate this to whatever data you're feeding into your chatbot. And so then what we do is when we look at the database tables for our users, what we're looking at is the information that we're actually only providing to our chatbot is the fields that we have approved are available to whoever the audience of the LLM results are. So we've removed a lot of the things that are PII. The things that we need obviously are zip code and first and last name, and they're kind of some of their transaction history. And then what you do when you're creating your prompts, you just simply tell it if you don't know the answer to this particular question, or there's a number of different ways of running the user query through a filter, essentially, that says you're asking for something that we're not going to provide for you for security reasons. Go talk to Bob in accounting, and he can decide whether you can know this information or not. Providing that second different level of filtering, both at the data level that you're feeding into the LLM and actually into your LLM implementation, can prevent a lot of that information. And if you know that the data isn't in there, then you know that it's going to be false. And so you kind of obfuscate from a security standpoint. But you want to prevent it by just saying, I'm not going to tell you revenue numbers, or that information is classified or whatever, and is not available for public disclose. And then providing a response that the LLM can respond with on how they can get that information in an enterprise setting.
Which directly leads, thank you, Andrew, that directly leads to a question of governance, right? Because a lot of this data, whether the data guardrails or even accuracy of data to prevent hallucinations and so forth, some of it can be automated through the tools, but there will be use cases, or at least even if there's no use cases where you need manual intervention, the stakeholders will want assurance,
right,
that the model isn't releasing data that they do not want to see released. So
yes,
how does one go about thinking about governance in this setting, in an AI LLM setting?
sure. So really what we want to first talk about is how to do this, and Informatica is a great tool for this, right? It provides a lot of data governance capabilities, as well as at the Snowflake level. It also provides you with a number of opportunities to provide row level security. So for example, if you wanted, in that example, the governance policy is just as important as anything else, right? Making sure from an Informatica or another MDM solution, determining who can see what data, and that the data is being populated from the right places and all of that. Now, Snowflake, the demo that we showed, it's actually querying against a table. And it's actually a Snowflake query, which means that you can use Snowflake's row level security restrictions at the database level to make sure that if Greg logs in and he only has access to certain users, say for a specific region, you can pass Greg's credentials in when you run the query and generate the result. Where if Bob or Susan logged in for another region, they would be able to see the data that they would be able to see, and that would populate into the query. That's as we've discovered over the past couple of weeks, data security and computer security can be very complicated, but adding belts and suspenders along the way can ensure that your data is only being delivered to the right people at the right time.
Yeah, and again, that definitely makes sense, because you do want proper governance on data, regardless of how good a set of guardrails you have, because you're never always going to be fully sure. And having heard of the perhaps few examples where data has been released in ways that the company did not want released, then that makes you even more cautious I suppose. The other thing that people I think struggle with, or maybe the question that our customers have is, what tools to use? And I ask that because you have some tools up here, Informatica, Snowflake, Python, but I mean, there is a multitude of tools, and Silicon Valley is really great at cranking out, new versions and new sort of capabilities. But the adoption and deployment of these in mainstream enterprise, that companies that we work with, is a whole different ballgame, right?
Yes.
And so how do you go about thinking about the tool set? Because there is a lot of, I mean, yes, we talked about Informatica is very good. Okay, fine. But there's not the end all be all. We have other things we need as well.
Right.
Talk to us about how we choose tools, or what are some of the ways in which you choose a set of tools?
Sure. So the important thing, especially in the nascent area of large language models, is the frequency of change. And so when you're selecting a tool, you need to make sure that you're able to keep up with the change. So the first little bit of this, right, when you're doing kind of this implementation, this prep work and this training build, you want to make sure that you have a strong master data governance management solution, and you want to make sure that you have a strong database. Now, the good news is that all the databases that are out there right now that are primarily in this space, Snowflake, there's a number of Azure options, and there's some open source versions. All those are out there for the databases. And so that's kind of set, right? Pick one that you like, that can be used in other applications, and kind of decide on that. Now, when we get to the iteration and implementation, for example, I've written the same code that I showed on the report analysis to use Google Gemini's function, but I've also set it up where I can use Meta's large language models as well, with similar but different results, right? And so what you want to do is you want to just bake into your solutioning on the last step that some of the components might change, or you may want to change model you want to use an open source model versus Google's model or OpenAI's model. And so that's one of the great things about using Python in this scenario, is that for a lot of the libraries that you use to build large language applications, including agents, chatbots, and just normal LLM work, they have the capability to abstract out what those model calls look like, so you don't have to worry too much about what the underlying model changes are going to do, but that you will have to iterate and analyze the results coming out of those different models, because they'll be different. And so when you're thinking about it, you primarily want to make a decision on whether you want to use open source with the pros and cons there, or a more established model with the pros and cons there. Usually price is the main factor there, as well as data privacy. And then once you've made that decision, you want to use a code base that is not going to be locked into any one of those things. So instead of using the APIs provided by those vendors, whoever they are, you may want to instead use a open source model and abstract out the logic one step higher, just so that you can make those changes. Because, for example, the model that I was using last week for the demo, for the report analysis demo, was decommissioned over the weekend. And so I had to change models. I didn't change any other code. I just changed what model to use. And so keeping that in mind is usually a very big thing to kind of reduce the cost of change, which will be kind of running throughout the next couple of years.
Yeah. Good. Look, we're at 9:50 Pacific. I think that's the time we had allocated for this thing, if I'm not mistaken, or almost. Let me go here. Well, there's two questions. What are the tools and technologies? We discussed that. What are the challenges of preparing data for different algorithms and models? I think we addressed that as well.
I think so.
So yeah. Okay, so I think with that, we will close this webinar. If you have any needs on Gen AI or data management in general, of course, we are, we are a consulting firm and we do this work for a living. So please call us. Otherwise, thank you for attending. Have a great day, evening, weekend, and do call us if you have any questions. Thank
And
you
just one
again.
other thing to call out, Nimesh, before we let everyone go. We do have two webinars coming up in August and early September. One that is very similar to the topic that we talked about today, which is when to use Gen AI versus when to use data science that we use in our recommendation engine. And then more importantly, how to trust your data where it really matters in life sciences, and how to use that trusted data to really drive innovations. Those registrations are either open now or open soon. Follow us on LinkedIn and you'll be invited to those things. With that, thank you so much for taking the time to hear us today.
Great. Take care. Thank you all. Bye.